In 5.3, we're going to be talking about the different uses of our sum and difference formulas, which this is the list right here. These are all the identities that we can use for the sum and difference formulas. Now, I often refer to these as formulas rather than identities, even though they're the same thing. I just like to call them formulas because we eventually, use them to evaluate. So we're evaluating right here, which means that we are going to find what is the number value that comes out of this. Now, one thing to note is that we're going to try to do this by hand rather than just go straight to the calculator, because we could go to the calculator and do sine of 75 degrees. That's not hard to do. But we're going to try to solve this by doing our special angles, and the formula that's going to help us out with that is this first sum formula, this sine of u plus v formula. Now, in and of itself, sine of 75, we wouldn't be able to do that by hand. It's not, that's not a nice angle for us. But if we use this sum and difference formula, we can actually split it up into two angles that are nice for us. Now, the sine of 45 plus 30, the temptation here is to want to say, oh, well, all I got to do is just distribute and do sine of 45 plus sine of 30. But that's actually not what happens. That's not what works in these types of problems. We have to follow this formula up here, because sine of u plus v is equal to all of this stuff put together, and that is a little bit different. So if we've got the 45 and the 30, we can call this one u and we can call this one v, and we can set this up. We start by just expanding it out. So sine of u, so sine of 45, cosine of v, so that's cosine of 30, plus cosine of u, 45, and then sine of v, so sine of 30. So we're just expanding all that out for right now, and then what we're going to do is we're going to evaluate each one of these individually, because now these are all special angles and we can do that. You might want to just take a second, pause the video to give it a try yourself, but I'm going to, in just a second here, share with you what are the values for each one of those. This would involve drawing a special right triangle and then using the sides to evaluate. So here goes. Sine of 45 is going to be equal to square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And then sine of 30 is 1/2. Once we have all of those, we're going to try to combine this together with fractions. We can multiply straight across. So that gives us square root of 6 over 4 for the first one. And the second one gives us square root of 2 over 4. So we are going to get kind of a weird fraction, nasty fraction, but we're going to leave it like that because we'd like to do this in exact values. We're trying to just do this by hand anyway, so trying to take the calculator out of it completely. When we have two fractions, we can combine them as long as they have the same denominator. So this is going to be square root of 6 plus square root of 2 over 4. We actually can't combine those two. We can only combine them if they're multiplying, so we just leave it like that. Now you can always check it on your calculator to see if that is the right thing, so maybe we do that right now just because we can. So we might look at then making sure we have the right mode, degree mode. So I'll do sine of 75 and I'll get that. Now I look at what I have right here and let's just make sure that that is the same thing. So let's see, parentheses, square root of 6 plus square root of 2, close those parentheses, divide that by 4. And good thing is that it is exactly the same thing. So that checks out, and that is how you use the sum formula to evaluate the sine of an unfriendly angle.